How's it going, guys? This is John Timothy Gallardo, and today I will perform our experiment number 1 about the basic logic gates, the NOT gate, the AND gate, and the OR gate.
For this experiment, we will need a breadboard, IC, 360 ohm resistor, LED, connecting wires, and a power supply. For the first part of our experiment, we will be using a 74LS04N IC. First, we will connect the circuit. So here's our inverter gate circuit. First, we will test if the LED will light up when we have a zero input. So we will connect it to the ground. As we can see, the LED light up. So when the input is 0, the output is 1. Okay. Next, we will test if the LED will still light up when we have a 1 input. So we'll connect it here. As you can see, the LED light stopped. So if we have a 1 input, we have a 0 output. For the second part of our experiment, the circuit is almost the same. We will just be replacing the IC with a 74LS32N IC. Move the resistor to the third pin of the IC. Add another connecting wire that will serve as the second input of the IC. Now we have our OR gate circuit. Now we will test if the both A and B input is 0. The output is also 0. When A input is 0 and the B input is 1, the output becomes 1. When A input is 1 and the B input is 0, the output is also 1. When the both A and B input is 1, the output is still 1. So in OR gate, if there is at least one input that is connected to 1, the output will be 1. Now, for the third part of our experiment, the circuit is the same with the previous part, and we will just replace the IC with the 74LS08N. Now we have our AND gate circuit. Now we will test when both the A and B input is 0, the output becomes 0. When A input is 0 and the B input is 1, the output is still 0. When A input is 1 and the B input is 0, the output still 0. When both A and B input is 1, the output is 1. In AND gate, if there is at least one input that is connected to 0, the output will always be 0. For the fourth part of our experiment, we will be using a 74LS11N IC. Now we have our multiple input AND gate. Now we will test when all input is 0. The output is 0. When A and B input is 0, and the C input is 1, the output is 0. When A and C input is 0, and B B input is 1, the output is still 0. When A input is 0 and and C input is 1, the output is still 0. When A input is 1, B and C input is 0. The output is still 0. When A and C input is 1 and B input is 0, the output is still 0. When A and B input is 1 and C input is 0, the output is also 0. When all input is 1, the output becomes 1. Therefore, in multiple input AND gate, if there is at least one input that is connected to 0, the output will be 0. Let's create the AND OR combination circuit. Now we have our AND OR combination circuit. Now let's test. If all input is 0, the output is 0. If both A and B input is 0, and the C input is 1, the output becomes 0. If both A and C input is 0, and the B input is 1, the output is still 0. If A input is 0 and both B and C input is 1, the output becomes 1. If A input is 1 and both B and C input is 0, the output is 1. If both A and C input is 1 and B input is 0, the output is still 1. If both A and B input is 1 and the C input is 0, the output is still 1. If all input is 1 the output is also 1. Now let's build the AND OR NOT combination circuit. And here's our AND OR NOT combination circuit. If all input is 0, the output is 0. If A, B, and C input is 0, and the D input is 1, the output is 0. If A, B, and D input is 0, and the C input is 1, the output is 0. If both A and B input is 0, and the C and D input is 1, the output is 0. If A, C, and D input is 0, and the B input is 1, the output is 0. If both A and C input is 0, and the B and D input is 1, the output is 0. If both A and D input is 0, and B and C input is 1, the output is 0. If A input is 0, and the B, C, and D input is 1, the output is 1. If B, C, and D input is 0, and the A input is 1, the output is 0. If both B and C input is 0, and A and D input is 1, the output is 0. If both B and D input is 0, and A and C input is 1, the output is 0. B input is 0, and A, C, and D input is 1, the output is 1. If both C and D input is 0, and both A and B input is 1, the output is 0. C input is 0, and A, B, and D input is 1, the output is 0. If D input is 0, and A, B, and C input is 1, the output is 0. If all input is 1, the output is 1.
That concludes our experiment number 1. So what you guys think about the basic logic gates? Let me know in the comment section below. Don't forget to hit the like and subscribe button. See you guys next time. Goodbye!